In this video, I'm going to show you how to integrate parametric equations so that we can work out areas bound by parametric equations and the axes. So just as a quick recap, we could find an area if we knew y equals f of x, so like a Cartesian equation, we could work out, for example, that area if we knew what the x values were along that x-axis. We would integrate f of x dx between a and b, and the a and b would be our x limits, so the values along the x-axis. So that's if we were doing it using Cartesian equations. Okay, if we wanted to work out that area given parametrically, then we would have to have two parametric equations. X might be some function of t, and y might be a different function of t. Then if we wanted to work out the area, then we would integrate the y parametric multiplied by the derivative of the x parametric with respect to t. So we would differentiate, we're going to differentiate the x parametric, we're going to multiply it by the y parametric. That will result in a function of a different function of t that we are then going to integrate with respect to t, and we will have two t limits, t1 and t2. They would be the t limits at these 2 points here. So if you are told the t limits, then happy days, we don't need to do much working out. If we have the x values, then we need to figure out what the value of the parameter is, the t value or the theta value, if it's in terms of theta, at that point. Then we're going to integrate with respect to t, and we're going to substitute in our t limits. So you need to remember that. You do not get that in the formula booklet. So I'm going to show you a couple of relatively straightforward questions. Then I'll show you a couple of slightly harder questions, and then I'll show you a complex question. So here's the first one. A curve has parametric equations x equals 5t squared, y equals t cubed. Work out y dx by dt dt from 1 to 2. So these are our t limits. Okay, so these are already values for t. So we need to multiply the y parametric, which is that one, by the derivative of the x parametric. So the first thing I'm going to do is I'm going to differentiate the x parametric. So dx by dt, if x is 5t squared, dx by dt will be 10t. So to integrate those parametric equations, I need to multiply y, the y parametric, which is t cubed. I need to multiply that by dx by dt, which is 10t. And then I need to integrate that with respect to t between my t limits 1 and 2. So if I just tidy that up before I do anything. So t cubed times 10t is 10t to the power 4 dt. So when I've multiplied my y parametric by the derivative of x parametric, the result is a different function of t, which I just need to integrate. So the integral of 10t to the power 4, if I raise the power and divide by that new power, so 10t to the 5 over 5 is going to be 2t to the 5 between 2 and 1. So if I substitute 2 in, 2 lots of 2 to the 5, take away 2 lots of 1 to the 5. So that's going to be 64, take 2, which is 62. Okay, let's have a look at the next one. So the diagram shows a sketch of the curve with parametric equations. X equals t squared, y equals 2t, 3 minus t. For the domain of the parameter, t is greater than minus 0. So pay attention to that. The curve meets the x-axis at x equals 0 and x equals 9. The shaded region R is bound by the curve and the x-axis. Find the value of t when x equals 0 and x equals 9, and then find the area of R. Okay, so had that not been there, this bit, we would have had to done that anyway, because to work out the area of R, we're going to use the parametric equations and we'll end up with a function in terms of t. So we need to know t values at 0 and at 9. Those are x values. We need to know what the value of the parameter is at those 2 points. So had we not been led into doing that, we would have had to have done that anyway. So to work out the value of t at x equals 0, I'm going to use my x parametric. So for part A, I'm going to say if x equals 0, then t squared will equal 0. So I'm substituting 0 into there, which means t is 0. Now I'm going to find out what the value of t is when x is 9. So when x equals 9, t squared equals 9. So t, well, it could be plus or minus 3. But if we refer to the domain of the parameter, t has got to be greater than or equal to 0. Therefore, we know that t has got to be 0 because t has got to be greater than or equal to 0. So those are our t limits. So now for part B, I'm going to integrate y dx by dt. So to do that, I need to know what dx by dt is. Dx by dt, if x is t squared, dx by dt will be 2t. So I'm going to integrate between 0 and 3. Those are my t limits. Y, which is 2t, 3 minus t, times by dx by dt, which is 2t, with respect to t. So I'm just going to expand that out. So I've got 2t times 2t is 4t squared, times by the 3 is 12t squared. And then I've got 2t times 2t times the t. So minus 4t to the power 3 dt. Okay, so now I'm going to, I'll just go up here, integrate. So 12t squared will go to 4t cubed. 4t cubed will go to t to the power 4 between 3 and 0. So if I sub in my limits, 4 times 3 cubed is 27, times 4 is 108, minus 3 to the power 4, which is 81, take away 0 minus 0. So the final answer is 27. Okay, in your notes booklet, you have those questions there. So before we have a look at anything more difficult, can you pause the video and have a go at the questions in your notes booklet? And then I'll show you the answers on the next slide. Okay, those are the answers that you want, those there. So hopefully you've got those. Okay, let's have a look at a slightly more complicated one. Okay, the way that this will get more complicated is, well, two things. Obviously the integration can get harder. So by the time you've differentiated x and multiplied it by y, you could end up with something that requires integration by parts or integration by substitution. Quite often they will use trigonometry, so that's quite a popular way of getting you to do more complex integration. So you might have to use an identity, you might have to do partial fractions, so anything where the integration could be made harder is likely. You're unlikely to get a question where the integration is as straightforward as what you've done. The other way that they could make it harder is if they do sort of a compound area, so where you have to work out an area from integration and then you might have to add on the area of a trapezium or the area of a triangle or take it away. So a more complex area. Okay, so that's how they're going to make it more difficult. Ultimately, you're just doing this. Okay, so it's the same formula. Depending on how many marks they want to give will depend on how complex the integration is going to be. Okay, let's have a look at this question. So the curve C has parametric equations. X equals t, 1 plus t, y equals 1 over 1 plus t. We've got the domain of the parameter is t is greater than or equal to 0. Okay, right, so the first thing, it says here, limits. The first thing I would do is convert my x limits into t limits, because remember we're going to get a function of t. Okay, so here that's x is equal to 0. Here that x is equal to 2. So to work out the value of t, I'm going to use my x parametric to figure out what t is at those two values of x. So if x equals 0, then I can say 0 equals t lots of 1 plus t. So that means that either t is 0 or t is equal to minus 1. Now t is greater than or equal to 0 according to the domain of the parameter, so that we can reject that and say t is 0. Okay, t has got to be greater than or equal to 0. So that's the first limit. If x equals 2, then 2 equals t lots of 1 plus t. 2 equals t plus t squared. So t squared plus t minus 2 equals 0. Just taking 2, moving it over. So if I factorise t plus 2, t minus 1. So t is minus 2. but again we can't have that because t's got to be greater than 0 or t is equal to 1. So those are my two limits. So I'm just going to make a note. T is 0 there and t is 1 there. Okay, so those are my limits. So now I'm going to integrate. To integrate, I need to know what dx by dt is. So if x is t plus t squared, okay, so again, think about the most efficient way of doing that. You could have used the product rule. Hopefully you've realised the product rule is not the most efficient way and you can just expand it out. Okay, so always look for the easiest approach. Dx by dt will be 1 plus 2t. Okay, so if we substitute it into here, we're going to integrate from 0 to 1 y, which is 1 over 1 plus t, times dx by dt, dt. So that's 0 to 1 of 1 plus 2t over 1 plus t dt. Okay, there are a couple of ways that we could do this. Okay, it's not recognition, so we can't just do it by looking at it as it is. Not partial fractions, because we can't factorise the denominator. We could use substitution, because the denominator's function is similar to the numerator's function. So that's one option. We could, if we wanted to, so we could let u equal 1 plus t and then go from there. The alternative is, I would probably do long division, so you could rewrite that, this fraction here, as a mixed number by doing a bus stop and dividing the top by the bottom. So I'll show you both actually. Okay, so I'll first of all show you the bus stop. So if I divide 2t plus 1 by t plus 1, so I've just switched them round because I need the highest power at the top, at the front. So if I do long division, t into 2t is 2. 2 multiplied by t plus 1 is 2t plus 2. And then if I subtract that, I'll get minus 1 as a remainder. So as a mixed number, that's 2 minus 1 over t plus 1. Okay, so instead of integrating 1 plus 2t over 1 plus t, I can now integrate 2 minus 1 over t plus 1 dt. Okay, the integral of that, well, the integral of 2 is 2t. The integral of 1 over t plus 1, so that's power 1 on the bottom, which means that's going to be a log. So it's going to be minus log of the denominator. Okay, but then we've got to divide by the derivative of the internal function. The internal function's derivative is 1, so that's not affecting anything else. So it's just that. So we've got between 1 and 0. So if I substitute 1 in, 2 minus log of 1 plus 1 is 2. Take away. 2 times 0 is 0, minus log of 1, which is also 0. So the final answer is 2 minus log 2. And that's the exact area bound by the curve. if I decided to use substitution, so I'll just go back to how I had it. I had that. So I could let u equal 1 plus t. du by dt is 1, so du is dt. And then I could also say that t is u minus 1. So if I substitute everything with a u in, I will get, so that will go to 1 plus 2 lots of u minus 1 over u du, which is 1, it's 1 take 2 actually, so minus 1 plus 2u over u du, which goes to, if I've got one denominator, negative 1 over u plus 2u over u is 2, and then you could go from there. Okay, once you integrate it and put t plus 1 back in, you'll end up getting the same answer of 2 minus log 2. Okay, that's the end of this video. In the last video, I'm just going to look at 2 more complicated questions that involve trig.